This is a very, very difficult question, especially considering where it is in the section, right? This is a number 14 out of 30 multiple choice questions in the calculator section. So it seems a little out of place because it's supposed to be kind of easy, you know, medium difficulty, and yet I think this is one of the hardest questions on this test. And so that's going to throw you off. But it's all the more reason, you know, if you hit something weird, you can always guess and move on and come back to it later. But I think the thing that makes this so difficult is it's a weird algebra situation. But even what I want to do here, guess and check, is kind of weird and confusing. So I will show you the algebra solution at the end. I think for some people it's very intuitive and they get it very quickly, but those people probably aren't watching this video. So I want to show you what to do when it's so weird that you just don't even know where to start. You don't even know what algebra to use. So luckily, when that happens, we often have a story. And we often have answer choices that are very straightforward in the context of that story, right? These are just the numbers, in this case, of the price per meal. And so that's something we can kind of work backwards from and understand through the story one step at a time, instead of trying to build equations that capture everything at once. So that's the benefit of guess and check, right? It takes a story apart and lets us go piece by piece. So let me kind of walk you through what I see, right? We have this initial fact that the restaurant is charging $12 per meal and it's serving 400 meals per day, okay? But then things change. And we see that for each 50-cent increase to the price, the number of meals sold per day decreases by 10. Now, first and foremost, if I'm going to work backwards from these numbers, like something like 16, I have this weird way of connecting what I highlighted in pink with what I highlighted in yellow, right? Like, in order to see the difference from $12 to $16, a normal person would just say that that's $4. But the question is kind of telling us that that's 8 units, right? It's 8 increases of 50 cents, which is so weird to think about. So what I would just do here to start is turn what's written in pink into something more understandable. Instead of thinking of it as a 50-cent increase that leads to a decrease of 10, right? So 50 cents leads to a decrease of 10. How about we do an increase of $1 that leads to a decrease of 20? And that works nicely because notice none of these answer choices have any cents at all. They're all in terms of dollars. So if I convert here, I can understand what's going on a little bit better. From there, I just need to think about how many dollars off from the initial 12 I am. So for choice A, I'm $16 different, or $4 different. So I would say, okay, well, if it's $4, right, an increase, this is choice A, an increase of $4 would be now 4 decreases of 20. So that would be a decrease of 80 people. So what does that mean? Well, instead of selling then 400 meals, we're going to sell 320. And if they're at this price, $16 per meal, I can multiply these two numbers together, and thankfully I have my calculator, so this is pretty easy to do. So 16 times 320 is $5,120. Now I have no idea if that's right? Because the way they're asking this, we want the greatest sale. So I have to do this 4 times and see which number is the biggest. So let's just go down the line here. If we do $20, right, so choice B, that is an increase from 12 of $8. So 8 times the 20, notice there's a ratio going on here, is a decrease of 160 people. So 400 minus 160 is 240. And then 240 times 20 is 4,800. So less, so that's clearly not the answer. But let's keep going, let's just be consistent here. So an increase now of $12 is going to lead to a decrease of 12 times 20, which is 240 people. So 400 minus 240 is 160 actual meals, and 160 times 24 is $3,840. Now it looks like it's going down and we might be able to just stop here, but to be honest, like, because this question is so weird, I would just be thorough. Why take a shortcut and risk getting it wrong? So choice D, $28 means an increase of 16. 16 times 20 is 320. So 400 minus 320 is 80 people, and 80 times 28 is 2,240, making that wrong and making choice A correct. it's a lot. That was, 5 minutes there of work. This is not a question that you'd be able to do super quickly, even on the real test. Like, I know I'm slowing it down for the purposes of explanation, but this is a 5-minute question maybe. This is something that's okay to skip because it's so weird. The algebra solution might be faster. I think certain tutors would kind of laugh at what I just did here with guess and check, but I think it's very common that the reason guess and check is better is that it gets you working through a question that you're otherwise just staring at. So if you ever find yourself in that situation where you're just staring at a question, hoping for something to come to you, try to use a strategy like guess and check instead. It gets you moving. It gets you involved in the question sooner, because if you're just staring, that's not a strategy. That's just waiting for something to come to you. And we could wait for a minute. We could wait for 10 minutes. We never know how long the staring is going to take. So start doing, and you're more likely to at least move the question along. What we could do, though, if we wanted to solve algebraically, is we could turn these sentences into mini equations, right? So when a buffet restaurant charges $12 per meal, the number of meals it sells per day is 400. For each 50-cent increase to the price, the number of meals sold per day decreases by 10. So there's two things going on. There's the price and the number sold. So let's kind of see what's going on here. Let's see what's going to change. The variable here is the number of increases in price, which is a really weird thing to make our variable, but that's what you're supposed to do. So then the price would be the $12 that we start with, plus 50 cents for every increase. Okay, so there's an equation. It's a linear equation. The other equation would be about the number of meals. So I'll say M, the number of meals, is equal to the 400 that we start with, minus 10 for every increase of the price, right? So the N is the variable that's kind of affecting both the number of meals we sell and the final price that we sell them for. Now, these are both linear equations, but in order to solve, we're not going to use a linear equation. We need a quadratic. Look at what we did in the guess and check. We multiplied things together. So we multiplied the price times the number of meals sold. We're going to need to do that here, but this time it's with equations. So what's going to happen is we need to do basically P times M, and that's going to be then the total sales. And we're trying to see which gives us the highest sales. So P times M is just going to be 12 plus 0.50 N times 400 minus 10 times N. So notice the two linear equations are now kind of looking like factors of a quadratic equation, and that gives me the sales. So from here, there's a lot of ways to deal with the algebra. The key component is that we need the greatest, which is the maximum, and that happens at a vertex. So we're basically looking for a vertex. One way we can do that is just kind of find the x-intercepts using this format and then kind of find the middle between them. What I think most people, though, naturally are going to do with vertex is they're going to use the formula, let's put it here. The vertex, the x-coordinate of the vertex is equal to negative b over 2a, which requires that we FOIL this whole thing out and get an actual, equation. So we could also graph it, right? We have our calculator, but many of us don't have these graphing calculators, so we might need to do it the hard way. So let's just FOIL, okay? 12 times 400, 12 times 400 is 4,800. 12 times negative 10n is negative 120n. 0.5n times 400 is plus 200n, and then minus, oh my gosh, this algebra is even in my head very tough, 5n squared. And that still equals the sales. So now what I would do is rearrange all this to ax squared plus bx plus c form. So that's negative 5n squared. These two terms combine, so that's going to be plus 80n, and then plus 4,800 is the sales, and negative b over 2a means we're going to do negative 80 over 2 times negative 5, which is negative 80 over negative 10, which is 8, but that's the value of our n here. So that is the number of increases that we have. In order to get the actual price that they want, we need to go back to our p equation. So we said p is equal to 12 plus 0.50 times n. N is 8, so that's p is equal to 12 plus 4, which is 16, which was the choice A that we eventually started with. Is that better? I don't know. I really don't know. This is one of those questions that's just very, very hard, and for most of us, it's not worth our time. You can get a 750 or better without ever worrying about this kind of question. There are always going to be 3 or 4 per SAT that are just about good luck, and maybe you see the thing you're supposed to see, or the strategy works and you can push your way through, but you can still do really well with the stuff that's much more predictable. I called this a WTF question. WTF models, right? It's a model, it's a story, but it makes us say WTF. That's okay. Sometimes they're just weird.